Good day, I'm Dr. T and welcome to my office. So today I would like to talk a bit about waves, a little bit more about waves, mostly waves plural. Wow, that was a confusing intro, wasn't it? Okay, so what am I getting at with this mess of an intro? When you have waves, of course, you know, you've got your wave, it's going through whatever its medium it is. Those waves can be interacting with other waves. So you can have more than one wave. And when waves interact with each other, interesting things happen. So the classic case is, imagine you've got, a stream and you've got some rocks. And as the waves come down through the stream or across the bay and they encounter the rocks are going to stop the wave from traveling because, the wave is going through the water, not rock. So the wave is going to be narrowed into a couple of choke points. And then the waves spread out as they leave those choke points, basically creating several new sources of waves. But as they spread out, now all of a sudden they start interacting with each other. They start colliding. And they can do a couple of things when they do this, depending on how they collide with each other. So if a wave would be coming over and one is coming peak and the next one is coming peak, then the two peaks are going to add together, and that's going to be what we call constructive interference. It's constructing and building an even tighter wave. Because imagine if one wave is making you go up and the next one's making you go up, it's like a double jump. And thus you're going up even higher. So in that case, you could see bigger waves than you would otherwise see. Alternatively, if you imagine one wave is coming up and one wave is going down, so it's crest to trough, then it's like you're going up and down at the same time. What do you call up and down at the same time? Not moving. And that's what we call destructive interference. In that case, you are canceling out one wave with the other. And this will create really interesting patterns of ripples when you see the two waves interacting. And features that can actually be quite useful for us. This is actually how noise canceling headphones work. If you've got noise, and if you want an active noise canceling, obviously just put something squishy that the waves can't travel through, that works too. But the active noise canceling ones will emit a sound that's exactly like the one you're trying to get rid of, but it is slightly set off from the one that you're trying to get rid of, so that as it goes towards your ears, the crest of that outside annoying sound meets the trough of the sound that you're using to get rid of it, and vice versa, and it cancels them out. It does destructive interference. This is actually a really cool, although really obnoxious demo. If you've got, say, a stringed instrument and you play two notes that are almost spot on, you'll actually start hearing this kind of a wobble. It's painful to listen to, but you will hear this wobble in the tone as you've got destructive interference between the two notes that are almost exactly the same, but not quite. And this is actually a trick that string players will use to help tune their instruments, because you can tune them so you get the wobble and then it goes away, and thus you know you're in tune, or you're really off. But hopefully you got ears to know if it's really off. This actually leads to another interesting feature of waves. Speaking of stringed instruments. And actually this is going to be for all instruments, but the stringed ones it's the easiest to see. So stringed instruments work by taking the instrument, say the violin, plucking, bowing, or somehow causing the string to go back and forth. As the string goes back and forth, you're creating waves in the string, and then those waves beat against the air, creating sound. Now, each string will only create certain waves, and this is how you tune the instrument, by changing the tightness of the string and by squishing part of it with your finger. And I'll try to do bad violin holding, but you know how it goes. What you're doing is you're lengthening or shortening the string. Really, you're shortening the string by pushing your finger down on the spot of it. This allows for the waves to go down the string, so the wave is traveling down the string, bouncing off generally your finger, traveling back, bouncing off the bridge, and just boing, 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 boing. Now, as the wave is traveling, some waves will interact and be constructive. So the wave going forward and the wave going backwards, if they interact such that they're constructive, then they will add together and will create what we call a standing wave. And that's where you have constructive interference of a wave that's going back and forth across the string. So one wave goes over, next wave is generated, bounces, and they cross, and they do so in a way that is constructive. But only certain waves will be constructive. Other waves will be destructive. And in that case, one will be going forward, the other will be going back, but then they'll cancel themselves out. This is why your strings have only certain sounds to them, because some waves will be constructive and others will be destructive. The other feature is on a stringed instrument, you notice how it's not a pure tone. If you have a tuning pipe or a tuning fork or one of those tone generators, it doesn't sound like any instrument you've ever heard. It's just like beep, really annoying. So instead, what's happening is you're creating the wave, one wave that will go down and back off, 2, 3, 4 different types of waves, actually hundreds, all of which are capable of being standing waves on that particular string. Because they get constructive interference because the distance to and from, they happen to line up nicely. But you won't have the other waves. What blend of these waves? Well, that gives you your timbre or your tone quality for that particular instrument. When a material is doing this, when it's able to bounce back and forth, we say it resonates. Resonation or resonating is the ability of something to be able to time the wave so that the push of the energy from the wave is happening at the same time that it's going in that direction. The classic example is pushing a swing. So if you've got a person on the swing and you push them, if you push them when they're swinging back towards you, you slow them down. But if you wait to the point where they're at the top, back into the swing, and they're starting to swing down, and then you push them, oh boy, you can get them going real high, to the point that they're like, stop, stop! It's great. It's wonderful. Don't do that at home. Be respectful to the person you're pushing the swing. And when they say stop, stop. Boy, is it kind of funny, though. You know, not saying to do that. Okay, so that is a little bit more of waves. And once again, have a wonderful day, and don't be a jerk on the playground.